Hello, everyone. I'm Anthony Kapkin, editor of Electrical Business Magazine, and your host for today's session. As the world moves toward electrification of everything, it's time to challenge conventional thinking about conductor materials. So I hope you're all ready for rewriting the spec when it comes to aluminum and modern electrical design. Here to challenge our conventional thinking is Pete Pollak, retired from the Aluminum Association, where he spent nearly 35 years leading product standards and electrical services initiatives. Also joining us for a discussion after Pete's formal presentation is Shelley Bacon, the CEO of Canadian company Northern Cables, which is generously sponsoring today's session. Northern Cables is a manufacturer of commercial and industrial power cables and an armored cable specialist, something of an expert when it comes to aluminum conductors. Now, without further ado, please welcome Pete Pollak.
Thank you, Anthony, and thank you, Electrical Business Magazine and Northern Cables for sponsoring this webinar. Why back to the future? The current advantages of aluminum over copper are enormous, yet copper is viewed as the metal of electrification. To understand how this can be, one must understand history. Most engineers, they learn about this, that. They don't learn about history. I'm going to give you history, several histories: history of aluminum, history of copper, history of the electrical industry. The advantages of aluminum over copper are enormous. 1 pound of aluminum provides the conductance of 2 pounds of copper. Aluminum costs roughly $1 a pound, copper $4 a pound. $1 worth of aluminum provides the same electrical function as $8 worth of copper. You also get some side benefits of reduced weight, price stability, and reduced theft. So these are the advantages of aluminum over copper. Let's look at the advantages over copper over aluminum. Copper has a higher volume conductivity than aluminum, 100% versus 61%. Copper requires less space, slightly less space. Copper has been branded the standard of the electrical industry for decades. Copper is generally considered as safe and reliable. Fire hazards, electrical fire hazards like fault and other things, are considered electrical issues, not associated with copper wiring, even though tens of thousands of fires involving copper wiring occur annually. There are a lot of misconceptions about copper and aluminum. The first one is, well, aluminum costs less, so you must be getting less, okay? Another misconception is aluminum doesn't have as much conductivity as copper, okay? In reality, it has 2 times the conductivity of copper per pound. And then aluminum has been branded by the US government as a fire hazard. So those are some misconceptions. Again, let's go into some of these things. Aluminum has twice the conductivity, 200%, the conductivity of copper per pound. One thing that's confusing is price and value, okay? Even though the price of aluminum is less, that doesn't mean you're getting less electrical capability. Let's look at an example. 500 MCM copper has the same conductance or resistance as a 750 aluminum, but the 750 aluminum will weigh half as much as the 500 copper, and the metal cost will be 1/8. It'll be 1/8 of the copper cost. Let's look at a practical application where this could really be a game changer. Electric vehicles. Replacing copper in an EV with aluminum can reduce the material cost, helping make EVs more affordable and reduce the weight, giving EVs greater range. Copper is on Elon Musk's radar. I've read reports that he's increased the voltage within EVs from the standard 12 volts to the 48 volts, higher voltage, less metal. But even with the higher voltage and the copper, he could switch to aluminum and reduce cost and reduce weight. History of copper. Copper occurs naturally in metallic form in nature. So that means that you might find a chunk of metal and it could be copper. It's already in the form of copper, the element, okay? Being so readily available, it served mankind well for 10,000 years, during which time fabrication techniques and alloys were developed, such as bronze. Aluminum, on the other hand, is never found in metallic form. Aluminum has an affinity for oxygen, so you never find aluminum in metallic form. But aluminum is everywhere. It's the third most abundant element in the Earth's crust, the third most after oxygen and silicon. Aluminum was first developed or isolated by Hans Christian Ørsted, a physicist. He was able to create aluminum by reacting aluminum chloride with potassium, I think it's ammonia, okay? And he got some aluminum. This is chemical reduction. Aluminum starts out as a rare, precious metal, more valuable than gold or silver. There were only ounces of it available in the world. So this is a rattle that Napoleon's grandson had made for his child. It's got gold, it's got silver, and it's got aluminum, a rare, precious metal. In 1884, we're going to the history of the electrical industry. It starts about 1884, Thomas Edison, the light bulbs, etc. Now, why was copper used? Copper was used not because it was the best electrical conductor, rather because in the 1880s, it was plentiful and cheap. Aluminum was a much better material, but there just wasn't much of it in the 1880s. It was also much too expensive. It's easy to say that. Let me give you a visualization to help bring that into perspective. In 1886, the Statue of Liberty, a gift from France, contained 200,000 pounds of copper. At about the same time, the aluminum cap on the Washington Monument contained 100 ounces of aluminum, and it was the largest aluminum casting in the world at the time. So there was plenty of copper, being plentiful, it was cheap. There wasn't hardly any aluminum. Aluminum could have been free. It just wouldn't have been used for electrical because there wasn't enough of it. In 1900, Nikola Tesla recognized aluminum as far superior to copper and predicted that when the aluminum industry scaled up production and the price drops, aluminum would not annihilate the use of copper for electrical applications. I usually don't use the word annihilate because it's a very strong word. It's not my word, it's Nikola Tesla. And Nikola Tesla has a pretty good track record in things electrical and predicting the future. So remember these two things. when the aluminum industry scales up production and the price drops. In the meantime, the electrical industry was growing and there was all kinds of electrical construction, and copper was used exclusively for electrical construction from 1884 to 1944. Nikola Tesla got a whole bunch of patents for motors and Tesla coils and all kinds of things. And what did he use? He used copper, not because it was the best, because it was readily available and cheap. So with this monopoly for 60 years, copper became baked into all electrical industry codes, standards, specifications. A couple of years later, the National Bureau of Standards ran into a problem. The problem was that copper wire supplied by different manufacturers, supposedly the same size wire, had various resistances. And this was a problem because if you're going to standardize and have specifications and construction, you need to be working with the same copper. So what they did was they did some round robin testing. They had 14 or 15 copper companies supply copper wire, and they tested the resistance of it. And to eliminate the variability, they set a certain value, and they said the value of copper to be used in electrical applications can't be below this, okay? And they arbitrarily set that that's 100%. Now, there's some things to realize about this. Number one, this was a copper-only deal. Okay, there were no other metals considered at the time. And number two, because the density of copper is what the density of copper is, weight was not considered. So this is a volume conductivity, which is now referred to as the International Copper Standard, ICAS, which was created in 1914. I like this caricature of the guy reading the standard. He says, if it's not in the standard, it can't be correct. Aluminum wasn't even considered. Weight is very important, okay, but it was not considered in IACS. Here's a copper atom. All the electrical function of elements occurs in the outer orbit of electrons. That's called the valence electron ring. That's what makes the electrical function. The protons, the neutrons, the inner orbits of electrons, they add nothing to electrical function. So weight is very important because all this weight of copper isn't really doing anything. It's just the outer orbit of electron that gives you the function. Again, you had a 60-year copper monopoly. Every electrical standard specification was exclusively copper, and copper became known as the metal of electrification. Quite a brand for the electrical industry. What changed? Okay, what's different? Little known fact, for World War II, the United States built 300,000 airplanes. And in order to build those airplanes, they built enormous aluminum smelting capacity. A lot of this was built during the Great Depression. They built electric generating facilities where there were dams. Then they had all this electricity they didn't know what to do with. And the aluminum companies built smelters near these dams. And I think that's probably still true today. Because of World War II, in the 1940s, there was a tremendous jump in the amount of aluminum that was being produced in the United States. And it was primarily for airplanes. And that has continued to grow even way much more since the end of World War II. Today, 3 times as much aluminum as copper is being produced globally. That's on a weight basis. 9 times as much aluminum as copper is being produced in the world today. So now aluminum has become plentiful, and owing to the economies of scale, has become relatively inexpensive. Let me refer you back to Nikola Tesla in 1900. He predicted this age of aluminum, and that's where we are now. But very few people recognize this. The aluminum smelters, they said, hey, we got a great metal here that conducts electricity really well. They went to the wire and cable manufacturers and they said, hey, how about we sell you aluminum and you make electrical wire and cable out of it? Well, at that time, the wire and cable manufacturers were owned by copper mining companies. And they said, no, we're not going to cannibalize our business to support yours. So in order for aluminum to be used in electrical applications, aluminum companies had to go into the wire and cable business. Okay, it was not a business that they would like to go into, but in order to get into that market, they had to go to the wire and cable business. Alcoa had Alcoa Conductor Products. Reynolds had Reynolds Electrical Products, Kaiser, Alcan, Southwire. All these companies with smelters went into the wire and cable business. Electric utilities were the first to switch from copper to aluminum. They recognized the value right away, maybe because a lot of transmission and distribution is overhead, and weight is really critical there. It determines the spacing between your towers and your poles and other things. So aluminum is used today in all transmission, all distribution. Between 1945 and 1955, the electric utility, all transmission and distribution became aluminum. And aluminum even started to be used where the utility lines end in buildings and in houses. 1972, the U.S. Consumer Product Safety Commission is created. One of the issues that it used to justify its creation was they noticed that there were fires in houses that had been wired with aluminum. This was over 50 years ago, but at the time it was a real big deal. They testified before Congress, they held hearings, and they declared that aluminum branch circuit wiring, sizes 10 and 12, was an imminent fire hazard. They even went to court and filed suit against all the manufacturers of aluminum wire and cable devices. The thing to note here is that aluminum wiring, in addition to being used by the utilities extensively, was installed in 1.5 to 2 million homes at the time. It's pretty hard to buck when the government says that you have a lousy product. They essentially branded it and have continued to brand aluminum wiring as a fire hazard. You can go on CPSC's website and they still produce a pamphlet repairing aluminum wiring. It's still available, and whenever CPSC electrical people speak, they still refer to aluminum wiring as a fire hazard. 50 years. I mean, That is unbelievable. While on the one hand, you got copper being branded as the metal of electrification, you have the US government branding it as a fire hazard. And then you have the National Bureau of Standards, which at the time was part of the US government. It's now been replaced by NIST, saying that it only has 61% the conductivity of copper. Actually, if the electrical industry were starting today, I could develop an aluminum conductivity standard, call it 100%. And then do you know what copper conductivity would be in comparison? 50%. 50% is a lot less than 61%. My personal view, what CPSC did was they discovered that aluminum wiring is susceptible to the same electrical hazards as copper wiring: overheating, loose connections, arcing, sparking, with one difference. They accepted that, if you're going to use electricity, these things can happen. That's why you develop things like the National Electrical Code to try and mitigate those risks. The one difference was that the only thing they noticed was aluminum. They said, this is different. So they ascribed those things which happen with all electrical circuits as unique to aluminum. It's been 50 years now, okay, and there are still the 1.5 to 2 million homes, and I might add, since we're talking about Canada, 400,000 homes in Canada with a 50+ year record of field performance, okay? I have personally petitioned the Consumer Product Safety Commission to review their aluminum fire hypotheses. This was a hypothesis. They found a couple of cases where there had been incidents. They did a bunch of laboratory experiments and they projected what would happen in the future. Well, the future is now, okay? And it's time to test their hypotheses against the reality. To date, I have not even received an acknowledgement of my petition. So, what happened since then? Okay, what had driven and what made aluminum viable for the electrical industry, even though it was much better than copper, was the companies went into the electric wire and cable business. Okay, in the 80s, with globalization, most companies had to go back to their core businesses. And the core businesses for aluminum companies was making aluminum. All these aluminum conductor companies, Alcoa, Reynolds, Kaiser, Alcan, Southwire. Well, Southwire is a little different. Southwire was a wire and cable company that bought an aluminum smelter. All the aluminum smelters, they got rid of their wire and cable company, and Southwire went back to its core business, which was just wire and cable. So there was a decoupling of metal producers from fabricators. And this didn't only happen in the aluminum business. I think it happened as well as in the copper business. So there has been no one to promote the production or sale of aluminum wire and cable. Now, aluminum made such tremendous inroads with the electric utilities and still in buildings and building in homes, it's still used. People just don't recognize it. It's used from the meter to the panel to the heavier circuits that feed air conditioning. But there has been no one to champion its further use or point out where it is being used. This normally would be the end of the presentation, but a friend of mine called me a couple of days ago and he said, Home and Garden TV series, season 6, episode 1. I looked it up, and what it was It shows a video of a house in Florida built in the 1960s. The contractor now is rebuilding the house, making it much larger, and he discovers that it has aluminum branch circuit wiring. So he advises the client to have it all pulled out and replaced with copper wiring because aluminum wiring is a fire hazard. I've never seen the house, but my approach would be, my God, this wire has been working there apparently for 60 years. They don't notice that. All they notice is what they heard from the US government and the Consumer Product Safety Commission. The client agrees and pays an additional $14,000 to have the work done. What I recommend is try and find this Home Garden TV series, look at the episode, and come to your own conclusions. Okay, so back to the end. It's not really the end, it's just the beginning. Now that you have the full story, we'll go to question and answers. Don't be bashful.
Very good. Thank you for that, Pete. I love it when you get into the history to track, where we were, 10,000 years ago with copper and people seeing it, understanding it, and starting to manipulate it. And aluminum really only coming onto the scene, but even then as a very expensive, rare thing, just only 200 years ago. I love getting that context from you.
Well, no, nobody else kind of has any feeling for this. And actually, that one slide with the electric vehicles, I said, man, aluminum would be great in electric vehicles. So I Googled Tesla and aluminum, and I came up with what Tesla said in 1900. He says aluminum, it's going to annihilate the use of copper. And that's part of the reason why, even though I'm retired, I've done this.
Indeed, indeed. I have some more questions coming, but I want to get Shelley to weigh in on one of the other green facets that are tied to aluminum. We've heard about the conductivity, the weight, and the price. But Shelley, before we get to questions, so there is this additional green facet to aluminum. It's been highlighted by the Clean Aluminum Educational Campaign. Uh, can you tell us a little bit more about that?
Yes, thanks for the question, Anthony. In the manufacture of aluminum, as Pete has pointed out, quite abundant in the Earth's crust. Aluminum is a very specialized process to refine, and it requires a tremendous amount of electricity. And historically in the world, electricity is made from, in the more advanced countries, they might use nuclear, they might use hydro. But unfortunately, in a lot of places, electricity is generated by burning fossil fuels to make the generators produce electricity. So when one produces aluminum, it produces with fossil fuels, you actually have a very carbon rich aluminum, which is the point I think that Anthony wants me to make. In Canada, in particular, we have all of our aluminum manufacturing in either British Columbia or in Quebec. And all of our aluminum manufacturing is made with hydroelectricity. So it's a renewable energy. It it has a very, very small carbon footprint relative to a lot of the aluminums that are made in other countries. And on the other point to make about this is we have these LEED buildings where they evaluate the 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 environmental footprint of the buildings. But a lot of people don't realize our current LEED standards have no consideration for any of the power cable that goes into any of the construction of the building. They worry about the siding, they worry about the insulation, they worry about the windows, the flooring, all this kind of stuff. But there's absolutely nothing when it comes to wiring. And if anybody out there listening has been involved in any kind of multi-unit construction, you will know that you have to bring the power cable in from the street. You know, you have to redistribute it throughout these large buildings. You know, you have to raise it up to all the various floors. And within any of the units, you know, you've got connectivity from the circuits, from the light switches, from the devices. So there's a tremendous amount of electrical cable and potential carbon footprint involved in any aluminum used in the construction of these buildings. So we're trying to encourage people in the lead industry to consider this when they update their standards for assessing lead consideration.
Interesting. No, that's an excellent point about the embodied carbon. Uh, and lead, you are referring to leadership in energy environmental design, the green building rating system. Okay,
Correct.
yes. Okay, yeah,
Yeah.
yeah. Just to be clear, and it's interesting that the rating system would look at the embodied carbon and the scope one, two, three emissions and all of that for all these other building materials, but not look at the conductor. I find that very interesting. So anyway, keep up that campaigning for the clean aluminum so that people understand, hey, there's this other thing that we should be looking at. Now, a couple questions have come in. And I'll read the question out to you, and then you guys let me know which one of you wants to take it on. So one of our attendees asks, how is aluminum a better conductor than copper if aluminum oxidizes more and has less mechanical strength? Who would like to take that one?
I'd like to take it, and Shelley can follow me if he wants. Uh, Aluminum does have an oxide coating, okay? And this is, it's an insulating thing and it's angstroms thick. That's like a millionth of an inch, like almost imperceptible amount, okay? As soon as you put pressure on that, it's like ice on a stream. It breaks up and the water or the nascent metal comes up through it and makes a good contact. This is brought up over and over. And in my view, it was one of the things that the Consumer Product Safety Commission, they decided, well, aluminum's a fire hazard, okay? And what is the reason for that? And they said, oh, oxide coating, they came up with a bunch of silly stuff, a bunch of experiments, okay? In the United States, Canada, all over the world has overcome this problem of oxide coating. Okay. Anybody who's ever screwed in a light bulb, if you look at the light bulb base, it's made out of aluminum. If you look at the lamp base you're screwing it into, it's made out of copper. Both of those aluminums have oxide coatings. You screw the light in and it works, contrary to the theories and experiments that the government has spent millions of dollars to say it won't. That was the oxide coating. Then there was also the mechanical. What was the second part of the question?
Mechanical strength.
Oh,
Mechanical
yes.
strength.
Yes, less mechanical strength.
Aluminum for electrical conductors, okay, it does have limited mechanical strength. The utilities have overcome this by having a steel core in these transmission lines. It's aluminum conductor, steel reinforced. Aluminum has plenty, more than enough strength for the other wire and cable applications. Aluminum's a whole family of alloys, okay? How strong is it? Well, you can have some aluminum foil and say, oh, this is not very strong. You could take a can and like bend it. This is not very strong. But look at an airplane. You're up there 20,000 feet in the air and you're depending on the strength of aluminum. The aluminum that's used in conductors, okay, has more than ample strength.
I would agree with what Pete is saying. Back to the oxide, uh, both copper and aluminum, as soon as one scores it or does anything to it, where the bare metal is exposed on the surface, immediately starts to produce an oxide. It's on both metals. It's not one metal, it's both metals. But as Pete had pointed out, the oxide is very, very thin. This is not a deep oxide. It's not that the oxide continues to build over years and years and years. And when you make a connection, there is a mechanical connection. And as Pete pointed out, when you make the connection, you break through the oxide and you reach the base metal. Um, the use of aluminum is if one looks out of their window as I can here now, and if I look at our systems we have in North America, all of the power coming to your home is sitting on the poles, as Pete pointed out, with ACSR, with a steel reinforcement member in the center of it because of the long links they run it. It has more than ample strength. It has been used extensively and growing in many markets. And the technology for terminating aluminum, whether it be on the poles or whether it would be within a residence, the technology for connectors has improved and developed significantly since the growth of this stuff in the last 25, 35 years.
Interesting. I want to stick with the physical properties because there's another question that came in, and thank you all for putting those questions in the question tab. We're going to try to get to as many as possible, but this one also deals with physical properties. So, is it true that due to its physical properties versus copper, aluminum is a softer metal and prone to greater movements with temperature swings? So, does it therefore require more maintenance to ensure it's properly installed and functioning properly? Who would like to take that
Nonsense.
one?
I'll take it, because I've heard this over and over. This is aluminum creeps, and aluminum creeps, copper creeps, all metals creep. Okay. The question is this a factor that can't be overcome? Is it of significant size? When you look at these transmission lines, these ACSRs, okay, they sag a certain amount, okay? And over 10 years at elevated temperatures, uh, they do sag more. Okay, so that's the creep phenomena, and the utilities know how to deal with that. But when you're talking about small dimensions like inches or even feet, this is not a factor. This is a bit of material science, okay? If you stretch something to below its yield strength, when you let go, it'll return to its original shape. And that's what happens in most cases of aluminum. Because the amounts, the size and everything, you don't get creep like you can get on an overhead transmission line several hundred feet long. Was there another part of that? Or?
No, I think that, I guess the second part is, yeah, you've answered part of this with the utilities knowing how to deal with that creep, but the second part was, so does therefore aluminum require more maintenance to ensure it's properly installed and functioning properly?
No,
Shelley, do you want to take the part two?
To add to Pete's answer, I just like to suggest, from my experience and knowledge, the aluminum found on the poles is typically EC grade 1350. It is elementally pure aluminum, and it's elementally pure and probably one of the softest forms of aluminum, although it's stranded, so it has, some mechanical energy in it. And to Pete's point, the way he mentioned, 0.2% offset on the yield curve makes the product elastic. So any kind of deformation springs back to where it was originally. I agree with all that. Now, for internal uses, in a lot of applications, the world has advanced by introducing alloy grades of aluminum for circuits where power may be on and power may be off. Not so much on the poles where you have a continuous load, but internal uses, they have developed 8030, 8176 grades, which is about 99.5% aluminum, 0.5% alloy, and that's meant to improve some of the creep properties that Pete has suggested. So the grade of aluminum that is now prominent in North America are these 8000 series aluminums, and they perform very nicely when properly terminated with the proper connectors in the proper situations. It's not going anywhere. The material is fine.
Excellent. Thank you for that. And because we're talking about installation, what I'm about to read next is not a question, but a comment. But I like it and I want to read it out. So, just a comment. I've been dealing with copper and aluminum wiring for the past 51 years as a journeyman electrician and as a professional engineer. Any failures that I have observed with aluminum wiring were related to workmanship, nicked conductor when insulation was removed, improperly made connections on screw terminals, lack of joint compound on larger cables, improperly torqued connections, etc. So to me, this sounds like someone who's been around the block, and I see this and I hear about this so often that people are very quick to judge a product, burn it at the stake, so to speak, and they're not perhaps looking at the workmanship that went into it. Pete, can you
If,
speak to that?
yeah, if I could comment on that, I'm sure that the person, I don't want to speak for them, they can speak for themselves, but I'm pretty sure that the same incidents of problems that this questioner is talking about, he's seen them in spades several times more in copper, okay? And he doesn't look for, gee, was it workmanship or this or that? They usually cut it out, replace it, and don't even give it a second thought. If it's aluminum, there must be something, here. And you put on your thinking cap and you come up with all kinds of crazy stuff. The fact is that for decades before there was aluminum used, copper was used, and you had these same things happening. And the insurance underwriters, to limit their losses, they said, hey, we got to test this stuff. We got to have a national electrical code, and whatever happens after that is just accepted. It's not associated with copper. Aluminum, being the new kid on the block with a bad reputation, given to it by the government. That can, all kinds of problems arise. Routine maintenance in buildings, hotels, electrical contractors come in and do infrared testing, infrared scanning. They're looking for heat sources, and then they try and correct them. They're not looking for copper. They're not looking for aluminum. They're looking for problems before they happen and get out of hand. A lot of times it'll mean something was loose, okay? Other times it might mean something is overloaded. Other times it might mean a circuit breaker is damaged and needs to be replaced. But mind you, if there's aluminum on site, it's not going to be a factor because they're only looking. They won't notice it. They're looking infrared. But if somebody without infrared inspection and this experience, they'll come away thinking, look, there's an aluminum problem. I'm not very handy. And when my air conditioning goes out at home, my wife says, fix it. You're an electrical engineer. I said, I'm so smart that I'm going to call a contractor that knows what he's doing. And they go in there, and then I say, what's the problem? And I've had them come up and show me some copper, and it's got a twist-on connector, and it's green, and it's overheated. And I said, well, how did you solve that? Said, we cut it out and we put a new connection in. If aluminum was involved, you'd get a complete story about how it's no good, et cetera, et cetera, et cetera. I might also point out, a lot of people don't realize this, but over the years, the electrical codes have changed. They've added things like ground fault interrupters, okay? They've added things like arc fault interrupters. And these are not for just for aluminum or for copper, they're for both. So a lot of the things that were happening and that continue to happen are basic electric phenomena, and maybe the equipment, depending on when it was built, they didn't have these interrupters, and stuff happens.
Exactly, exactly. Shelley, do you want to weigh in? Possibly agree with Michael, who's been around the block and sees workmanship as a bigger issue, and it's not a product specific issue.
Sure, I would just like to reinforce what's been said so far by the caller in and Pete as well. We operate several factories that operate 7/24, and as a good maintenance policy in a factory setting, we do two types of inspections of our systems here. Obviously, the main panels, for exactly the reason Pete brought up. Alternate years we use infrared, and on the other years we actually go in and do some mechanical uh, inspections of these devices, because if something happens in the factory setting, maybe the load changes further down the line, maybe something's going on and it could present as other problems, and it isn't necessarily the wiring. It could be a connection somewhere else, it could be a device that's not functioning properly, it could be the breaker, it could be a bunch of stuff. So for anybody using these materials, it's just good common electrical sense. If your home is being modified, if you're doing things, it's a good thing to have someone with the appropriate tools to go in and perhaps do an infrared shot of your connections, and just make sure that heat pump you installed, make sure that hot tub you put in, make sure those lights you ran to the end of the driveway, make sure all of those things have been installed properly with the right termination techniques, because we all know a lot of people like to do things themselves and cut corners, and that's where you can potentially get into difficulty if it's not done by a licensed practicing contractor.
Well, and to your points, I mean, in Canada, we have CSA Z463, maintenance of electrical equipment. I may have butchered the title, I can't remember exactly, but it shows that we have guidelines, we have reasons for maintaining our electrical equipment, and it's not specific to maintaining equipment because aluminum's involved. It's just maintaining your electrical equipment. So it's important to do. I want to get to another question here because Pete, you had mentioned insurance a little earlier during one of your answers. So one of our attendees is suggesting that we need to deal with insurance companies because they are requiring homeowners who may have aluminum branch circuits to switch that out. Now, is anyone challenging the insurance companies? Why are you forcing people to switch out the branch wiring?
I don't know of anyone challenging insurance companies. And I think the insurance companies have a great ally in the Consumer Product Safety Commission, which has perpetuated this urban legend, this myth that there's something wrong with the aluminum. There's nothing wrong with the aluminum. Well, there might be something wrong with the electrical system, the way it's operating, but the aluminum is not the problem, okay? Even the Consumer Product Safety Commission, they say that where the problem is at the connection point, okay? I would say at this time, that's why I petitioned the Consumer Product Safety Commission. You've got hundreds of millions of these connection points out there, and they should be looked at and evaluated against the theory. That's the way the scientific method works. You don't just come up with a hypothesis, do some experiments, and saying this or that is going to happen in the future in millions of cases. That's what they did. Now the chickens are going to have to come home to roost. They're going to have to be counted. Insurance companies, their laws unto themselves. They do whatever they want to do. Actually, it was the insurance companies that started Underwriters Laboratories and that started the National Electrical Code. I think over the years, Underwriters Laboratories, CSA in Canada, and the Canadian Electrical Code and the US Electrical Code, they have moved away from their original parents, which were the insurance company, and they're doing their own thing. And the insurance companies are trying to do their own thing. Doesn't mean it's right, but that's what they're doing. And, you know, I'll never forget this one lady called me up and she's crying. And I hear a baby crying in the background. And I was working at the Aluminum Association. What's the matter? And she says, she just found out she had aluminum wiring in her house. So she's in the dark. She's afraid to turn on the lights. And I said, how long have you lived in the house? She says, 20 years. I said, have you had any problems with any electrical things? She says, no. And I said, why do you think you have a problem now? She says, electrician told me, or a home inspector, or someone told me I have aluminum wiring. The best information I could give her was, I have no idea of what's going on in your house, but regardless of what they have told you, you're living there and using it for 20 years. You probably know more about it than they do.
And it seems to be working. We only have a few minutes left, so I just want to, and we still have so many more questions. We won't be able to get to them, but I will take these questions that we didn't get to, and I will send them to our speakers and try to get answers for everybody after the fact. But I want to close with this one question. I'll ask Shelley, and then I'll ask Pete. Um, Anybody who's on the call, who's watching this right now, if there was just one thing you wanted them to walk away with, one changed habit or insight, what do you hope it would be? Let me hear from you first, Shelley.
That's a daunting question, Anthony. Um, when we first entered the aluminum conductor business at Northern Cables, I recall that it was something that was sort of unique to the province of Quebec and the province of British Columbia. There was not acceptance or any consideration other than utility in any of the other regions of Canada. Everything else had to be copper. And we've had a lot of places that have specified copper in the past because, as Pete says, through default, that's the way a lot of the code books were written in the past. But what I have noticed in the last 25 years, and especially in the last, I'll say 15 years, is that the use of aluminum has grown tremendously in a number of products that are used, the majority being in commercial applications where the wires are stranded. And the use of the new alloys, the 8030s, the 8176s, has made for the manufacturer and for the use quite practical. It is a cost-saving measure. We very much want people to keep in mind on this seminar that aluminum produced in Canada is made from virtually carbon-free sources. The aluminum that gets imported into this country from other places often is very, very carbon rich. And I can only hope that our listeners and influencers take this into consideration in the future when they are talking about LEED design buildings. Thank you.
Excellent. Thank you for that. And just very quickly in our final few seconds here, what about you, Pete? One takeaway
Uh,
that you want from our attendees.
Okay, this is not the end. It's just the beginning. Now that you know the full story, what I think is going to happen, education is the key. Okay, and I think what Tesla foresaw is going to happen. The price of copper dances around and keeps on going up, up, up. There are people that are predicting, they say buy copper stocks because there's going to be a shortage of copper with this re-electrification of the world and education. And then, in the valley of the blind, he who has one eye will be king. Now, hopefully, you could see with two eyes.
Excellent. And I love that you toggled over to this slide to be our closing slide. That's perfect, Pete. So just to quickly wrap things up, we are at the 1 hour mark. On behalf of Electrical Business Magazine, thank you, Pete, for coming on and sharing all this history and facts. And Shelley, thanks for bringing your wisdom and being in the market, being a manufacturer. You also bring that facet to the conversation. So I thank you for that. And thank you, Northern Cables, of course, for helping us deliver this information and hopefully change some minds and help people to rewrite the spec. With that, thank you, gentlemen. Thank you, attendees, and have a great day, everyone.